My name is Eric Griffith, and this is a little bit of a map of where I've been and how I came to learn how to code. So we're here in Houston today. I was born here in California, way over there. But I grew up mostly in Rhode Island, this little teeny tiny state from last year that probably most of y'all have been to. Then I went to school at Rensselaer Polytechnic Institute upstate New York, where I got my bachelor's degree and later my master's degree in computer science. Although I started coding when I was still in high school back here in Rhode Island. And then after that, I went way over on the other side of the ocean to the Netherlands, where I spent about 9 years. And I went to the Technical University in Delft, very beautiful little city there, where I got my PhD in computer science, doing lots of fun things to create cool pictures and see exciting things, and lots of data that people were working on. So these are a couple examples of things that I personally coded over the years. So way back when I was in high school, I made a Tetris video game that I thought was just fantastic, and I put that out there on the internet in the early days. And some people out in Germany still have it on the internet so that you can download it. I also worked on, in the early days of the internet, a file sharing application that Mr. Corbin would not have liked. But we were paid pretty good money when I was in school to create a program to let people share music that set the foundation for what a lot of you probably experience today, where you go to iTunes and you buy the music that you download and listen to on your phones or your parents' phones or your computer. I also got to work when I was in school in the Netherlands on virtual reality. So I have some kind of fancy goggles on, where when I look at this special table, the things on the table look to me like they're floating above the table or floating below the table. So you can do a lot of cool stuff when things look like they're floating in space in front of you. And I also worked on a couple of other things where we created pictures of little drops of fluids that were moving around for future medical applications, where you can imagine these are little chemicals that are mixing to form medicine in a more efficient way, or can do medical tests with a little tiny finger prick instead of taking a big needle and sticking your arm, sucking a lot of blood out. And I also worked with people that were building simulations of clouds. So they did a whole bunch of very complicated math and ran programs for many, many hours. And they could eventually generate some clouds, but they could never see these clouds. So then I came in and I wrote a faster program that ran their same math much faster. And so interactively, you could see these clouds as they were forming. So that was while I was in school. And then after I left school, I got more into the industry, or one of the biggest industries here in Houston, which is the oil and gas industry. So I've created applications. I can't show you the real applications, but these are similar to what I've worked on, that are used for finding oil and gas and then helping people drill wells or poke a bunch of holes in the ground and get it out. So this picture on the bottom here, this is a bunch of rocks way down underneath the ground. And you see this kind of S-shaped thing here, and that's what used to be a riverbed many, many millions of years ago. That's filled with sand and all kinds of dead critters that over many years turned into oil and gas. And then people use software like this where they can see these sorts of things to figure out, aha, that's where we want to go and drill a well, and that's where we want to get the oil out. And then people will come along with their little oil rig, like big oil rig, and they'll set it up over top of one of these things. And a bunch of guys like this will be out on this part of the oil rig doing fairly dangerous work to help people actually drill a hole very deep in the ground to try to get the oil and gas out. And so in an effort to try to keep things a bit safer, they try to get people not to actually be out here messing around with heavy machinery and equipment that could, if things go wrong, seriously hurt them. So there's people like this guy over here that sit in an office here in Houston or in Louisiana, in New Orleans or other places, and they look at a whole bunch of computer screens. And on these computer screens, they look at squiggly lines like this one, And these squiggly lines tell them what these guys out on the drilling rig are doing. And these guys in the office have a lot of experience understanding how this process works, and they're out there saying, you know, you guys out at the rig, you're about to really mess something up badly. You need to stop what you're doing, and you need to do something else. So these people can keep an eye on a whole bunch of drilling rigs and all over the place. So Texas, Oklahoma, out in South Dakota, out in California, all over the place where people are drilling rigs or drilling wells, to monitor these things and help keep people safe and keep the cost of drilling these wells pretty down. So I've worked on software that helps people make these pictures, and I've worked on software that helps create these squiggly lines that people in the office use to look at drilling. So that's a little bit about who I am and what I do in software. But I want to tell you a little bit more also about what else software is out there. So you all have done coding, so you kind of understand what software is. But you know, if anybody's ever put together furniture from IKEA, that's essentially what software is. It's a series of instructions telling the computer, which is pretty dumb, what exactly it needs to do to solve the problem that you have in mind. And I think most of y'all are pretty familiar with the most common places to find software. So you find it on your computer, you find it on your phone, you find it in your video games, if you play video games. The websites you might visit, like Google and Facebook and YouTube, all of these are powered by software. But what you may not be familiar with is that software is everywhere. It's in a lot more places than just on your computer and on your phone. So there's people out there building robots that look like people or don't look like people. Those are all powered by software. If you ever watch the weather forecast on TV or on the internet, all of that is driven by software. What you see, the pictures you see are created by software. The mechanisms used to forecast the weather are simulations that are run by software. There's really cool technology in cars these days that are all powered by software. There's medical devices in hospitals like MRIs, CAT scans, X-rays. All of that uses a whole bunch of software to make the pictures that look inside your body. Things like the power networks, these are wind turbines generating energy. They are controlled by a whole bunch of software that tells them when can they turn, when can they not turn, where should the power go. Aircraft, airplanes, helicopters, all of these have an immense amount of software in them that help them do what they do on a day-to-day basis. And one of the coolest things, I think, is, you know, there's software off this planet. There's software on the moon. There's software in the Mars rover on Mars. And this picture here I really like. This woman is Margaret Hamilton, and she's standing next to thousands and thousands of pieces of paper. And these are what she and her team created to help fly the moon lander to the moon. So her software, which is printed out in these papers, is in this lander on the moon today. So I want to tell you a little bit more about working in software now. So if you're interested in coding and you want to do coding, you might be wondering, that's great, how do I get a job in software? What kind of jobs are out there? So I think when most people think about working in software, they think about, I want to solve puzzles. You know, I like figuring out why something doesn't work or how to make it work. And that's a software developer or a coder or a programmer. That's what you all are learning to do right now. But those aren't the only jobs in software. There's also people, like these gentlemen, who like to break things. Their whole job every day is to try to break the software so that when you get it, it's not broken anymore. And that's quality assurance. Their job is to make sure that when you get a piece of software, it does what it's supposed to do and not what it's not supposed to do. There's also people that ask a whole bunch of questions. They go out there and they talk to people that don't understand coding, they don't understand how to make software, but they have very important work to do. And they need somebody to write a software application for them so they can do their job. So this could be like the fingerprint scanner Mr. Corbin uses, or it could be many other things. And these people go out and say, well, what do you need to do? How do you do your job? How can software make your life easier? And then they go and tell these guys, the software developers, how to build the software. And you also have people that are not involved in creating the software, but they write down how do you use the software. They write down the facts that you read to help you understand it. They write the instruction manuals on how to use the software. And there's a whole bunch of other jobs out there like that. And then sort of in the middle of it all are people that like project managers or people like myself that tell the software developers what to work on and how they should try to solve the problem. So to tell you a little bit more about what specifically I do in software as a software development manager. So I don't write code myself anymore. I have people that work for me that write code. And I'm kind of like a fortune teller. I try to predict the future. When are we going to be done? How hard is it going to be? How many people do we need to work on this to get the problem done? And I track our progress. We got to get all of this stuff done, and we're doing this. When are we going to be done? Are we going to be done on time? And then I try to work with the team that works for me and say, does everybody understand what we're trying to do? Do you understand how to solve the problem? Do you have what you need to solve the problem? And then I also try to look in at the end and say, how well did you do? Did you do it good, or do you need to keep working on it and try to do it better? So I got 2 more slides to talk to you guys about. So the first one is, if you're interested in working in software, what are the upsides to doing that? Why would you want to choose software, and why is it a nice career to think about? A lot of it revolves around, when you work in software, you have a lot of freedom to do what you want because your skills are highly valued. People really want you to do really good work for them, and they want to pay you a lot of money to do really good work for them. So a lot of that involves with, you get a lot of flexibility in when and where you get to work in a lot of environments. You can work at home, maybe in your pajamas sometimes. You don't have to talk to somebody on Skype. A lot of places have really cool office environments. This is a Google office somewhere where they've got a climbing wall, and some woman is climbing, in the middle of her day instead of writing software because she needs to take a break, clear her mind, try to solve her problem away from the computer. This one is a little bit more relevant for Houston. If you have to be at work every day at exactly 8:30 in the morning, you are going to be sitting in traffic a lot in a city like Houston. Nobody wants to do that. If you work in software, you often have the flexibility to say, you know what, I'm going to come in at 10 o'clock today, or I'm going to come in at 7 o'clock today, so I don't have to sit in traffic. Or when you have families of your own, my child is sick today, I need to take her to the doctor, take him to the doctor in the afternoon. That's fine. Take a couple hours off, make up the time that you can, and work around it. The pay is pretty good in software. It's one of the better paying jobs that you can get out of school, and that's going to continue into the future. And probably for me, the best reason is you get to have a lot of fun working in software. Software is all about solving problems, solving fun problems, understanding what people need to do with computers, what they want to do, and giving them tools that help them do that. And so you get to work on something that should be a lot of fun. Your job is not something you do because you have to. Your job is something you do because you like to. And you get to work as part of a good team. So software is not something you do on your own. It's something you do together with others. So my final tips to you are, how can you be successful in software, and particularly in coding? That's what I did before I got to be a manager. So at first, software seems like it's kind of hard. You can have problems you don't know how to solve. You get stuck thinking about them. There's no way I can do that. So what you need to remember is writing software, like many things, takes a lot of practice. It's not something you get good at overnight. You need to keep trying and keep going and keep working at it, and you'll get better at it. And you need to remember, it's not something you have to do alone. If there's a problem that you don't know how to solve, you can get somebody else to take a look at it with you. You can talk it over with your friends, you can talk it over with a group of people and say, how do we solve it? And you need to break it down, the big problem, into small steps and take it one step at a time. If you try to solve the whole problem, like if you said, I want to write Facebook myself, I want to create Facebook, that's a lot of work. But if you say, I want to create a simple web page that says, this is my name, that's pretty easy. And then you can take the next step and say, well, what if I let somebody else log into my web page? And then what if I let them add a friend? And then what if I let them add a picture? And then what if I let them do this other thing? And you just build it up gradually over time. You don't solve the whole thing. And again, the important thing is when you face problems, you need to think carefully. The details really matter in computer science and software. You know, if you spell the word wrong, it's not enough to have all the right letters. They have to be in the right order. You have to look at the problem very carefully and figure out which one of the details might not be right, and fix that one detail. If everything is not right, the whole thing is not right. So you have to think carefully, and you have to be positive and say, you know, I know I can do this. I just need to keep trying. I can get it there. And then in the end, you and your team together can be successful. And you can have what I hope would be a fun and rewarding career in software. Do you have any questions? Yes?
When you said that you created a video game, what was it called?
I called it Tetris because it was supposed to be like Tetris. Yes.
If you put a video game on the App Store, for $2, how does it go to your money? Like, does it go on your credit card or something?
Well, first, Apple takes a whole bunch of that money before you ever get to see it. And then once a month or something like that, once you've sold enough of them, they deposit on your bank account.
Yeah.
Checking account or something like that. You have a question?
Why did you want to be a coder?
Because I thought it was a whole lot of fun to solve problems. I started off creating really simple programs, like how old are you, what do you like to do, and then took a class in high school, so you all are much more fortunate to start at this age, and it was so much fun to solve these problems that I just kept going. So I love solving problems. That's why I became a coder.
And how much money do you get every month?
It depends on, software can be all over the place, but if you're fresh out of school here in Houston, you can probably get a salary of something like $70,000 a year. That's fresh out of school after 4 years of bachelor's degree, and then it can go anywhere up to, if you stay a coder yourself, $120,000, $130,000, $140,000 a year. It can be a pretty good job.
The money your teacher would never be able to make.
Coding is getting easier these days because you have a lot more tools to help you do what you want, and you have a lot easier ways to write code. So when I started, there were no web pages that you could go visit to. Everything was DOS, which you've probably never even seen, where you had to type everything in words. And now you have a lot more things that you can approach, where there's like pictures and robots and things that you can move around and create cool things, and 3D printers, and a lot easier ways to get started on my side.
What inspired you to start coding?
So when I was a kid, my father is a doctor, and I really wanted to be a doctor. He sat me down and said, "You do not want to be a doctor. You have to work so hard to go through school for so long, and spend so many hours. You don't want to do that." I said, "Well, shoot, I don't know what to do then." And when I was a kid, I really liked playing video games, and so I thought, I really wanted to know how to make a video game, and that was kind of my original inspiration. But over time, I realized that I like to play games, but I don't want to make games. I like to give people tools to do their jobs. So I don't want to be the guy building a house. I want to be the person giving that person the tools to make the house. That to me is a lot more fun. So understanding what problems people have and understanding what they do, and then giving them the tools to be successful, that's what really inspires me.
Okay, say thank you, guys.